Namaste. Welcome to the Indian Knowledge Systems Primer Course for Children offered by Anaadi Foundation. In this particular Bharatiya Ganita lecture, we will look at computing cube roots. Now, as we saw that there are 8 arithmetic operations in Bharatiya Ganita, we have seen some of these in our previous lectures, and today we will look at the 8th one of the list, which is the Ghana Moola or the cube root. As you may remember from our previous lecture, we saw the demonstration of this particular algebraic identity where we saw how to find a cube using a plus b whole cube, where the cube will be a cube plus 3a square b plus 3ab square plus b cube. In this particular lecture, we will see how we will reverse engineer this same identity to find cube roots. Just for our understanding, we will now see how computing a plus b plus c whole cube is not very different from computing a plus b whole cube as we did before. If we take a plus b as one unit, then our expression becomes a plus b whole cube plus 3ab whole square c plus 3a plus b c square plus c cube. This particular algebraic identity is employed in finding the cube as well as the cube root. Now, to perform this particular function and understand how to find out cube roots, we go back to Aryabhata and his Aryabhatiya. Let us look at this one particular rather cryptic verse which is used to compute the cube root given by him. We will listen to the verse now.
अघनाद् भजेद्वितीयात् त्रिगुणेन घनस्य मूलवर्गेण वर्गस्त्रिपूर्वगुणितः शोध्यः प्रथमात् घनश्च घनात्.
Now, let us try understanding what method this particular verse is trying to explain. Now, before we start computing, there are some points we must note and some rules we must remember. First is, if a number has n digits, the number of digits in the cube which are possible for a single digit number will either be 1, 2 or 3. For example, if one has to find the cube of 1, it is 1, which is a single digit number. If one wants to find the cube of 2, it is 8, which is also a single digit number. However, if we see, the cube of 4 is 64, which is a 2-digit number, and the cube of 9, which is the largest single digit number we have, will be 729, which is a 3-digit number. So, we can see that a single digit number can have a 3-digit number, 2-digit number or a single digit number for its cube. So, if a number has n digits, the number of digits in its cube which are possible will be 3n, 3n minus 1 or 3n minus 2. With this in mind, Aryabhata prescribes to group the number of digits starting from the units place of the given number whose cube root is to be found into 3 parts. Now, let us pay some attention to what these 3 parts are because they are very important for our calculation. These 3 groups are Ghana, Prathama Aghana and Dvitiya Aghana respectively. Now, let us dig into an example to see how the method can be applied. Let us say that we want to find the cube root of 17,71,561. As we can see, we will start from the rightmost end and move this way. So, the first digit we encounter, we will mark as Ghana. The second will be Aghana 1 and the third will be Aghana 2. Once 3 digits are complete, we start again with a Ghana. So, we mark Ghana, Aghana 1 and Aghana 2 in the same way. Again, since we are left with one more digit, we will mark it as a Ghana. This process we have to do first as soon as we take our number for which we want to find the cube root. Now, let us take the digits in the first ghana, which in this case is 1, and subtract the largest possible cube from it. So, the largest possible cube which we can subtract from 1 is 1 cube. Remember, whenever we subtract a cube from our digit, we add it here to our cube root. Subsequently, whenever we subtract a cube from a ghanasthana, we will add it to our cube root here on the right. Next, we bring down 7 from the dvitiya aghanasthana. So, whenever we bring down a digit from the dvitiya aghanasthana, it must be divided. What will be divided by? We will divide it by 3 times the root squared we have so far. In this case, it will be 3 into 1 square because that is our current root. So, now we divide 7 by 3 into 1 square, which is 3. Our quotient which we get is 2 with a remainder 1. Next, we bring down 7 again from the prathama aghanasthana, giving us 17. Now, we are encountering a new rule. Whenever we bring a digit down from the A1 place, we must subtract thrice into the root we have so far into the square of the quotient. In this case, this will be 3 into 1. As you can see, 1 is the root we have so far, and the quotient from our previous calculation is 2. So, we will compute 3 into 1 into 2 square, giving us 12 and 5 as the remainder. Remember, in order to crack cube roots, there are only 3 rules we must remember. First, whenever we encounter a digit in the ghanasthana, we must subtract a cube from it. Whenever we have a digit in the dvitiya aghanasthana, we must divide it by 3 times the square of the root we have obtained so far, as you can see here. And finally, when we have a digit in the prathama aghanasthana, we must subtract 3 times the cube root we have so far and square it with the quotient of our previous calculation. We will repeat this process subsequently to find the cube root. Next, let us bring 1 down from the ghanasthana and subtract the cube of the previous quotient available to us. Here it will be 2 cube, which is 8. Now, since we have removed a cube, we must add it to the root here. 2 will be our answer. 43, when we subtract 58 from 51, we get 43. Now, we must note that while in the first step here, we subtracted the greatest possible cube from the ghanasthana, subsequently in each step, we will subtract only the cube of the previous quotient we have. So, in this case, which is why we took 2 cube in the calculation, and we added 2 to the cube root here. Next, let us bring down 5 from the dvitiya aghanasthana and divide it by 3 multiplied by the square of our current root, which is 12. So, we will divide it by 432, which gives us 1 as the quotient and 3 as the remainder. Next, we bring down 6 from the A1 place, giving us 36. Continuing the same step as before, we will subtract 3 into 12, which is our current root, into 1 square, which is our previous quotient squared. So, 36 subtracted from 36 gives us 0. Finally, we bring 1 down, which is the last digit left in our calculation from the ghanasthana. Now, since our previous quotient was 1, we must subtract 1 cube from it, and since we are subtracting a cube, what we must do is we must add 1 to our root number. Our calculation ends here and we find that the root of this particular number is 121. That is, the cube root of 17,71,561 is 121. Let us take another example. Now, let us say we want to find the cube root of 13997521. We first of all start by marking the ghana and aghanasthanas. So, starting from the rightmost, moving this way, we mark the Ghanasthana, the Prathama Aghanasthana and the Dvitiya Aghanasthana, so on. We continue this till our last digit. Now, in this case, you will observe that our last digit is a Prathama Aghanasthana. When such a case happens, we must take the digit till the Ghanasthana. So, here we will start our calculation with 1, 3 put together, that is 13. Repeating the same process as we did before, we will subtract the largest cube possible from the first Ghanasthana. In this case, it will be 2 cube, that is 8. We subtract 8. Remember, since we are subtracting a cube, we will add it to our root number here on the right side. Beginning next, now we have 5 as a remainder. We bring 9 down from the Dvitiya Aghanasthana and divide it. Since it is coming from a Dvitiya or an A2 place, we divide it by thrice into the root squared we have so far. Since the root squared we have so far is 2, we divide it by 3 into 2 squared, which is 12, giving us a quotient of 4. So, 12 into 4, 48. So, our remainder remaining is 11. Next, we bring 9 down this way, and since it is come down from the Prathama Aghanasthana, we will subtract. What will we subtract? We will subtract 3 into our root 2 so far, which is our root digit, and square of the quotient from this calculation. So, 3 into 2 into 4 squared is what we will subtract from it, which is 96, giving us 23 as the remainder. Following the same process, we bring 7 in the Ghanasthana down. Now, since we have gotten it from the Ghanasthana, we must subtract a cube from it. So, here because the last quotient we had was 4, we have to subtract 4 cube in this particular case. Since we are subtracting a cube, we must add it to our root digit. Subtracting 4 cube, which is 64, right, what we get is 173 as the remainder. Continuing our calculation, we bring 5 down from the Dvitiya Aghanasthana and repeat the same process that we did before, right. Whenever we bring something down from the A2 place, we must divide it. So, we will divide it by 3 into 24 squared, because our root now is 24. We divide the number by 1728, giving us 1 as the quotient here. And now, once we have brought 7 down from the Ghanasthana, we must start our process again with the first rule, right. Whenever a digit is from the Ghanasthana, we must subtract a cube from it. Since our previous quotient is 4, we will subtract 4 cube from this number. So, 4 cube will be 64, right, and since we have subtracted a cube, we will add it to our root here, right, making our root 24. Once we subtract this, the next step we will get is to bring, now when we get a number down from the Dvitiya Aghanasthana, like we did before, we must divide it by 3 times into the square of our current root. Now our current root is 24, so we must divide it by 3 into 24 square, which is 1728. This is where us learning to compute squares comes in handy, as you will see. So, once we compute 3 into 24 square, which is 1728, we perform the division. Our quotient will be 1 and we will subtract 1728 from 1735, giving us 7 as the remainder. Next, we bring 2 down from the Prathama Aghanasthana or the A1 place. Remember, just like before, whenever we bring a digit down from the A1 place, we must subtract 3 times the cube into the square of our previous quotient. So, it will be 3 into 24 into 1 square, which is 72, giving us 0 as the remainder. Finally, 1, which is the last digit left in our Ghanasthana, will be brought down, and since it is in the Ghanasthana, we must subtract a cube from it. So, we will subtract 1 cube from 1, giving us 0 as the answer. Since we removed a cube here, we must add it to our cube root. Therefore, the cube root of 1399751 is 241. Now, I invite you to try computing this cube root of the number given here on the screen. Remember, once you mark all the sthanas, to take into account the digit till the first ghana sthana which you encounter. So, in this case, this will be 143. I hope that you will pause the video here, do the calculations and check your final answer. Now, moving on, let us take another example to see where the cube root might get a bit tricky for us. Let us say we want to find the cube root for 14886936. We start as usual by marking all our sthanas and start computing with the first ghana sthana taken into account. Here that is 14. We subtract the largest possible cube, which is 2 cube, 8, giving us 2 as the cube root in the right hand place. Next, we bring 8 down from A2, giving us 68, and since it is in the A2 place, we divide it by thrice into the square of our root so far, that is 2 square. So, we divide it by 12, giving us 5 as the quotient and 8 as the remainder. Next, we bring 8 again down from the A1 place, giving us 88. Now, as per our rule, we must subtract thrice into 2 times the previous quotient squared, right. So, 3 into 2 into 5 square, which is 150. However, you will notice that it is impossible to subtract 150 from 88, and therefore, we must revert back to division. How do we revert back to division? We go back and take 12 into 4 instead of 5, put down 48 and get a bigger remainder, which will be 20. Again, going forward, we bring 8 down and now we try subtracting 3 into 2 into 4 square, which is 96, and this is how we can continue our calculation forward till we get 0 as the remainder and our root is found. I urge you again to try this rather tricky sum. The only trick here to remember is when you cannot subtract a larger number, go back to your division and go to one digit before it till you are able to form the subtraction. So, here we can see that the root number for 14886936 will be 246. Feel free to pause at any step, do your calculation and cross check with the video. So, you would have noticed that all the square roots and the cube roots we have calculated so far have been perfect squares and perfect cubes. However, the methods or techniques which we are using are also relevant and valid for decimal roots and decimal cubes. I hope you apply this to several numbers, play around with the technique and master it so that you are able to compute both square roots and cube roots very quickly. I hope you enjoyed this lecture on cube roots. Thank you.